toast is ready. My toast is ready. So it's weird. You know, toast comes out of the toaster and then it just doesn't stay hot for very long. So maybe I need to toast it at lower levels of toaster setting for multiple times so that the heat goes in and like stays in the bread. I don't know. I want hot toast. I don't know how to get. I don't know how to get the. The shader. So we have this thing where we have a material catalog and it's got all these materials, and the materials can have parameters with like default values, and some of those default values could be texture maps. Let's not worry about that yet though. Let's try building this. Ugh. Oh, this is Wait, what? This is a pointer to material. But material info is render material. I don't know why we have two different things. But for now, oh, whoops, this is not, these are all textures. Lol. Okay, so what is the frickin' materials down here? What is that? Shader name. Oh boy. Yeah, I don't know how to decode this right now. We're gonna not worry about it yet. We're gonna run, and we're gonna see. We're gonna see. So we were at 4166 lines before. We should be quite a few more lines, because we're adding probably most of the textures in the game now. All right. I mean, I probably should be putting materials in the manifest. Like, we're going to want all this stuff, right? Except I don't fucking know. Maybe this doesn't do any. So the thing is, I don't actually know why there's two different things. It's like maybe one is the old thing and one is the new thing. But then why don't we just clean that up? Okay, that at least has a catalog asset name. This doesn't. So like, I don't know what is. No, it does, because it's got Oh God. Oh wait. Render material. This probably isn't a thing. Okay. I actually don't know if we need to load the materials. Okay. So we actually ran texture compression on some stuff as a result of this. All right, so we'll go back to our manifest file. It's only a couple hundred lines longer. We should probably sort. Should probably sort these. Just for reproducibility and readability, right? So we had a lot of textures before. They're all the double underscores. Okay. My theory is this isn't really supposed to be used anymore, because we didn't get that much out of it, but there's maybe some old meshes in the game that still use it. So I'm going to have to figure out how we get these. What do I think about Doom 1993's memory management technique, zone memory? I don't know what zone memory means, but it sounds like just having different areas for different kinds of allocations that you know the lifetime of. And the answer is, yeah, that's absolutely how you should do memory management. It's just a thing. You'd say zone memory or derivations of it is one of the biggest reasons to issues like Heartbleed bug. Okay, well, you're not a good programmer. Sorry. Like, that has literally nothing to do with Heartbleed. Do you even know what the Heartbleed bug is? No offense, but if you're going to say stuff like that in this channel, I'm going to call you out on it. That's just the rules. You can't just say nonsense, okay? You have to, like, actually know what's going on. All right. Boy, I sure woke up in a good mood, didn't I? Didn't I? Yeah, it is tea time soon. The thing is, I got a sparkling water that I'm making my way through first, but we're going to do some Golden Monkey today because I haven't had that in a little bit, and it's really good. Dude, 40 months. That's so many months. That's like a year. That's like a lot. Why not coffee? Because coffee's gross. Golden Monkey tea is so much better than coffee. Divide this large block into smaller ones, keeping all the blocks linked together in a list. Yeah, I mean, so the thing you have to understand about why this is done, why this makes sense, is if you treat all of memory as a single heap, right, and you use something like malloc on it over and over time, it kind of degrades. Initially, it's very easy to find large blocks of memory if you need a relatively big chunk, right? But then you free that, then a smaller chunk takes a portion of that space, but not all of it, and it leaves a thing called a fragment, right? And as you allocate and free from this heap over time, you get more and more fragments, right? And you could have a relatively large amount of free memory, but it's all divided up into smaller fragments that are smaller than the actual memory that you need to allocate next. And so you can run out of memory while having a lot of free memory, all right? This is the problem. And that's one of many reasons to constrain things like this, but it's like, well, and then the second reason is, you know, the way that people are taught to program in school Like if you've got a game like Doom, well, people in school have no idea how to make a game like Doom, right? But the way they imagine it is, okay, when we loaded up all the assets, we went and we ran malloc on each one of these. And now that it's time to unload the level, we're going to go and run free on all of them so we can free them from the global heap. And that's actually really slow as well, right? If you know you don't need anything in this level, just don't need anything in that level anymore. You want that to be as fast of an operation as possible. You don't want to go over, back in the day, it would have been thousands of assets. Now it's hundreds of millions of assets and like run free on each of them. That's absurd. So what you do is you just say, I don't need this heap anymore. And it's like a couple of instructions, right? And then you're done with all that memory. That's the other reason to do it. And so it's a very effective way to both keep, well, and then the third reason is because things that are used together are probably going to be referenced together. So if you keep them close to each other, you have better cache coherency. Whereas if you keep them far away from each other, then your program is slower for that reason too. There's all sorts of reasons to do this. So, yeah, and Doom was probably, I don't know, like, okay, here's the thing to say about this too. I was going to say Doom was a relatively early game to be that organized about it, but it's hard to say because there was sort of this continuum in games, right? The earlier games, like from the 80s, certainly did their own memory management, but they didn't ever come from this sort of academically affected school of like, here's how you abstract. Like they didn't, games in the 80s didn't know about malloc probably most of the time, right? They just picked some memory as they needed it. And then it's only once you got into this C-style programming with large global heaps that people even started to think about memory that way. And, it's a little bit convenient sometimes, but it's a little bit inconvenient because there's a lot of confusion about like, did I free things and whatever, right? Anyway, so those are the reasons why you would do things that way. Silver Moon Tea. I don't think I've had that. How do you allocate memory like that in practice? Write your own malloc replacement? No. Okay. So the secret is that any modern malloc implementation lets you have as many heaps as you want. It's just C programmers aren't used to it because C malloc doesn't have a heap parameter, right? But like if you download, like, okay, so in Braid, for example, which came out in 2008, so I was doing this in 2006, I used DL malloc, which was one of the better mallocs available at the time. And I just, every time I needed rewind data for a particular level, I just made a new DL malloc heap, right? And then when we unload that level, I just release that entire heap, right? And that worked very well. And it actually solved a problem because the reason I did that was because I had too much fragmentation on the Xbox 360 and the game was crashing from running out of memory, even though it didn't use too much memory, right? So that solved that. So that's, if you actually need heap style allocation, you just do that, right? Or, you can do what people these days call a bump allocator or whatever, if you just know that you don't need to free anything, right? The only reason to use a heap algorithm like that is if you need to free some things over the lifetime of that memory, right? And not other things. But if you know you want to free everything at the same time, then you don't even need to do that, right? Now, in this programming language, it is common to set the allocator to different things. And so people know that you could have different heaps that way. Whereas C programmers tend to not really know that you could have different heaps. Nothing about Rust is fast. In fact, Rust has some stuff that makes it slower than C++, like mandatory security checks. And the fact that, there's a weird thing in Rust that I'm not sure how it comes out in balance, right? So one, the Rust, borrow checker model sort of means that you don't end up with as much pointer chasing around nodes as you do in other languages, because you like literally can't do that, right? And that's annoying when that's what the program you want to write. But the upside of that is you probably don't take the speed hit that you get from bad cache coherency of pointer chasing all the time, right? So Rust programs might encourage speed in that way, but they also encourage data copying, right? Again, because of the borrow checker model. And so I don't actually know for a large program how that comes out on balance speed-wise. I don't think it's obvious enough that you can just say either way, right? But like the mandatory security checks definitely add some slowdown. How would you adjust that strategy for something like The Witness, where it's a continuous scene for the whole runtime? So in The Witness, we have all the assets in the game divided into different zone packages, I believe. This might be wrong because I didn't write this code, but I believe there's like a number of zones through the game. Like we don't load it entity by entity. We load it zone by zone. And each zone would just be packaged together, and you would just release all that memory at once. And that's probably how we do it. Modern operating systems can allocate memory also on your drive. Well, you're thinking about that a little bit weirdly, but that's kind of true. Okay, what do we do now? Do we... Let's output the materials. We're going to put these materials and those materials, and then, oh yeah, I want to sort the output. And to do that, we're going to factor this. So most of the, we can do our favorite new trick. We can do our favorite new trick. Okay. All right, we're just going to make a function that says, so we're going to call it like the following. These two lines here for level sets is going to be output table to the builder, level sets, right? That's going to be the section name. We're going to pass the table and the code to do for each one, right? Rather than having to like write a lambda or WTF, we're just going to go like that, right? So let's write this function, output table, string builder, name is a string, table is a sum table. And then code is code, and we're gonna go print the name. All right, and then we're gonna go for value key in table. There we go. All right. So, boom. All right. So we output table. Now we're gonna change this in a minute after we get it to compile. But okay. So we want to convert all of the. Actually, let's make sure this one compiles before we copy pasta. Table set. Oh, that's a different thing. Attempt to insert a non. Oh yeah. Oh yeah. Don't forget that. Change the type of that. Key.name. Name is not a member of string. Wait. Level sets. Table. Level sets. What? Really? Name is not a member of string. Oh, that's just because. All right. I thought that was the new code we were writing, but it was again the materials thing. Never mind. Okay, great. I was looking up here. I was like, what's wrong with that? Okay, so we're going to do this, and then, usually we just want to output the key if it's a string, but then sometimes it'll be that, right? And in fact, we could make it so you don't have to pass that parameter usually. But first, let's do all these. So, levels, textures, meshes, materials, shaders, and maybe we'll add more later. Who knows? And then levels, textures. Right now, it might seem like, well, why can't we generate something that'll do the string or what? And for something like this, it's not really worth it. But also, we might want to change these independently of these, because these are things that are part of the file format that like the other program is going to look for, right? And so we don't want the file format to break if we like rename a variable, right? So you actually want to decouple this stuff. Even though it looks like you might not want to. Okay, now most of these are key, but the meshes, and in fact, we could automate that part. We could automate that part in 1 second. We don't even need that parameter. All right, let's make sure this runs, and then we'll do the sort and remove that parameter. All right. Why code and not just a string parameter? I don't know. Because it's funner. But we're about to get rid of that parameter anyway. If Heartbleed guy is still here, I didn't mean to be that grumpy. It's okay. So the deal is, the thing that we pass in is either going to be a string or a resource, right? So we could do the following thing. We could say, and we're about to rewrite this anyway, but we could say if t dot key type is equal to string, you know, we could do this. Else, we assume it's got a name. So we say key or key dot name, right? And if we do that, then the caller doesn't even have to think about this at all. And we can get rid of that. Right? Great. That's even better than what we did. Why hash in the if? Because it's a static if. If this is a non-static if, right, then it means that both of these lines have to compile. But you don't want to compile this line if it's a string, because a string isn't a struct with a member called name. So this actually would not compile if this was a non-static if. Look, I can show you. I can show you. So that's why that's there. Okay. Now what? Well, we actually want to sort the things. We're going to go for. Well, we're going to do the same for loop, except instead of printing to builder down here, we're going to do that later. Instead, we're going to go, so first we're going to go strings is an array of string. Strings.allocator is temp, array reserve strings, table.count. And here we go, array add strings key or key.name. Okay. And then we print, okay, so then we go for strings, print to builder, it, but before that we say quick sort strings compare strings, right? Boom. All right, let's try that out. See, I've really enjoyed working in this language. So those of you who caught yesterday's stream as well, or whichever day it was, when we were working on this file, like this is the sort of thing that I used to write in Perl or something, but like it's totally fine to do it in this language now. In fact, it's better because you get better type checking and all these things. Like you don't have the Perl experience of like agonizingly trying to figure out what you got wrong. It's really nice that both we can do low-level video game stuff and high-level file stuff like in the same language, and it's fine, right? I really dig that. Okay, so we write out all these tables. What's her job? Tables. How much do polymorphic functions affect the end XE size depends on how much you use them with different parameters. Yeah, that's exactly right. Do they still need to parse into a valid syntax? You mean what's inside the static if? Yeah, it parses what's in there. It just doesn't type check it, right? So it does have to be valid syntax. And I felt like that was the right trade-off back when I was designing the language because, you know, I was familiar with all these problems from C++ where like you don't set a define for a long time and the code inside there has decayed somehow and you don't know, right? So this doesn't totally prevent the code from decaying because like it might refer to identifiers that no longer exist or something, but you know, it at least can't be total mush in there. Tables. I don't think she should have yelled at Eddie. Tables. Okay. Let's look at our new manifest. Oh, look at the alphabetical order. Look at that. This is levels. Levels. I might want to put new lines in here. You know what? We're going to put new lines just to make it easier. Textures. Oh, how many lines are we? 5,000. So we are definitely adding a little more. Of course, we're sorting lexicographically, not so these numbers like come out a little different, but that's fine. Yeah, so we still don't have that many textures that are not those screenshot textures. That's like the thing that we need. And then shaders, we're not putting anything yet. So this is great. It's working great. Does that mean that the static if will generate different code for type string versus struct? Yes. I mean, it just generates, I mean, this or this, right? That's the point. That is the point. Okay. Am I familiar with the Circle C++ compiler? Nope. But C++ is already way too complicated. I don't really want anything that adds things to C++. It's just already too much of a disaster. It is already too much of a disaster of a language. We need to move on. Okay. Now what do we do? Now, I don't know. I don't know if shaders can have... All right, let's see. Let's go look. This is not a thing, probably. Okay, so these are just your usual things. Sensible macros in a non-functional programming language. Well, we're trying to do that here too, and it's not fully baked yet, but it's showing promise. It's showing promise. Okay, so I have this thing where I don't know what to do with material here. So I'm going to go, like, for example, in the editor to the material panel, which is a thing that draws and lets you see what's going on. And I want to know... Okay. So, hold on. So this is the entities materials. Oh yeah, we might have done this. Oh no, we don't. Okay, so for m e dot materials, ugh, copy pasta from material panel. If this is a standard thing, we should probably factor it out and clean it up. I don't really... So basically what we're saying here is the entity can have a materials array. Those could be set, in which case we use them. Else, we get it from the mesh. Okay, so no check-in, make sure meshes are loaded. Maybe our load level goes and loads all the meshes. I think it does. But yeah. Okay, so instead of array add if unique, we're going to go table set, right? Manifest dot materials m dot name true, right? See, okay, this is kind of sketch right here. This is kind of sketch. Else log error material index is out of range. The entity's materials array is longer than its meshes materials array. Right? It index continue. Okay, so we're yeah. This, I don't love the way that looks. Okay, but anyway, okay. Let's just do this. No, that doesn't really mean the same thing. Okay, anyway. So we're going to get all these materials. Okay. I still don't know what to do with the materials, which is why we're looking here. Oh. Interesting. Okay. So if that's a material, table set m, no, table.materials m true, great. Okay. What else? So we get, okay, this is just for showing, yeah. Okay, so what do we do with this material array? I don't know. It's flag editing. Parameters. Why is this shader color only? Okay. Okay, so we can iterate over the materials shader parameters. Right, so for value key materials, we're going to say M. Whoops. Shader is m.shader color. Right, or sorry, if no shader. Robustness, Y only shader color. Wrote this by looking at, can other shader slots have textures by default? Question mark, I don't know. Okay, so reload if dirty, then we're going to iterate over the parameters. And we're going to do some stuff. We're going to say, okay, vector parameters. Bool. Int, float, vector 2, vector 3, vector 4, text or 2D. Okay, so if p dot, what did we say? Type is equal to case texture 2D, we need to do something there. What is R? Active value dot value. I don't, okay. So we're going to need to figure that out. Active value is get material parameter putter. Oh, I hate the fucking abbreviation putter. I can't believe somebody did that in this code base. Oh, burn it with fire. Okay. P.name. I don't know what all this recurse and skip disabled is. Okay, we'll have to look that up later. That's a little bit sus. Anyway, I have no idea what this means. So r.s is just the name of the texture. So we're going to go table set textures r.s true, right? Because we do the table find later. Okay, so that's texture 2D. That was it. Okay. I don't know. We might get a lot more textures now. Shader color is not a member of string. Oh, our materials table is material names. Okay, so the problem is we have this two different materials scenario. Right, we have this render material and this material. These ones are materials. Here's what I'm going to do. I'm going to make two different things. Two different things. Okay. And I think we delete this one eventually. All right. And this one is material pointers. Okay. And now that's correct. But okay. So this is render materials. This is materials. Okay, and then down here, these are materials, I think. Tables. Manifest is materials. Okay. Tables. How's it going, everybody? Manifest. Boom. We're going again. Not putting default entity mesh materials. Let's see. We've just reached the point where this code is starting to feel like I don't remember what all of it is, right? It's just really interesting. We've reached that point during this stream where it went from simple to like, Oh, you're right. Yeah, because I was going to like factor this down to the bottom, and I deleted that line in order to do that. And never put it back. Whoops. So let's do that. That is a good catch. You're using D, and that's a mistake. Why? Like my impression from D, so I looked a bunch at D I mean, not a bunch, but some when I started this language. And my impression was it was generally much cleaner and nicer than C++. I think D added some things that were weird and not necessary, like the contract oriented stuff. But if you ignore that, it's fine. One of the biggest problems for me is that A, it is still C++ at its core, and then B, all the way you make stuff on the heap all the time by default, and the garbage collectedness. All methods are virtual by default. Yeah, that's not great. That is not great. I mean, I know why he would make that decision. It's just to simplify the layout of how things work, but it is not the right decision, in my opinion, because one of the huge pains in the ass of C++ is the so-called non-POD types, right? Which we do not have in this language. Everything in this language is a POD type. And as soon as it moved away from that, C++, that's one of the areas in which C++ is a disaster. Okay, let's see how big our manifest is now. 5736. It's like we got some more textures. Well, I feel like we could load the manifest now. $. Okay. Dollar signs are variables. We should not output those to the manifest. Those are just ways for materials to reference render targets. But at least we know that that's working. I mean, it looks like we're getting textures that we use in the game. This doesn't, to me, seem like enough. So I'm a little wary here. But maybe it is. Maybe it's the textures are sort of atlasy. So we go from 822 to 1555, 752. Maybe that's enough. But what we're going to end up doing is running the packaging with this. And eventually, I think the place we're going to get to is we're going to throw out a bunch of textures because they're not in here, implying that they're not being used, right? And then we'll try running, and it'll be like, oh, we're missing some, and then we'll figure out why we're missing them. Anyway, though, this is pretty good. This is one of those weekends where it's like, dude, I wasn't even thinking we were going to do this for a long time. But here we go. Okay, so let's write some code that reads this in. So that's going to be in our package program. And what we're going to do is we're not going to run the rest of the packager right now because there's no reason. We're working on the manifest. I'm going to put it in this program, but we're going to say load manifest if, and actually we're going to return anyway. Okay. And for all the sections that we have in the main program, we're going to have stuff here, except they're all just going to be strings because we don't have these data structures in this program, right? So these are all going to be tables that map from string and tell us if we have the thing, right? So we're going to have textures. I'm just going to write them out separately. We could use comma, 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 right? Comma chameleon. Okay. All right, so name is a string. Start file. Start file on the handler. Right? And then we'll say if handler.failed log right now the manifest file must be placed in the working directory from which you run this packager program. Later on, we will probably let you specify it from the command line. Or defined to an absolute path via setting manifest path and recompiling. Like if you're going to do something, kind of hacky and weird like this, where it's like, look, I just put the file in the place and do it. Then when it goes wrong, tell people exactly how it went wrong and how to fix it, right? Okay. So let's just look at our example here. So we go start file. We're using like break by spaces kind of stuff in here. Okay, so Okay, line found is consume next line handler. Log error. Return false. Oh yeah, this is a return false. Okay. Prefix, section prefix. For some reason, I made it 5 semicolons. Actually, so the text handler has an error function. That says the file and line. Unable to find the section prefix, whatever here. Right? Okay. Advance line. All right. If line is equal to textures, right, else this is interesting. Because we want to go down, we want to do all these sections. I guess we'll have a table that we're putting stuff into. We'll say a table is a pointer to a table from string to bool, right? While true, we just keep going around. If line is equal to case textures, right? Okay. Here we go. Oh, actually, we don't even need this. So if it begins with a section prefix, we do all of our things, right? So meshes, levels, level sets, shaders, and materials, right? These are all the sections that we know. All right, Emacs is going to be annoying. All right, these are all the things we know. Oh wait, error, handler, unknown section header, whatever, line. All right, so that's fine. I'm not going to fight with Emacs on this indentation. Someday maybe I'll fix its indentation. All right, so here we just say table equals manifest, here we'll return false. Hold on, manifest.textures, and so on. Here we return false. Okay, so then we continue. By the way, let's not even do this. Like, let's just do this, right? We consume the next line. If we never set the table, that's an error, right? Do we want to validate that we saw all sections? Okay. Otherwise, it's just a regular entry. So it's just a line like any of the texture names or mesh names. And if that's the case, then we say, well, if we don't have a table yet, then we error handler received a line, received an asset tag without a section header starting with whatever telling us which section it goes in. Return false. Section prefix. Right? Otherwise, we'll just say table set, table. We'll trim the line just in case. This is a little bit, actually, we're not going to trim the line because I don't think we sanitize asset names to make sure that they don't have like spaces in them at the end, right? So if I cut a space off the end, that's bad news bears. Okay. So if we get down to here, we're going to return true. We loaded the manifest and then load manifest. You know what? I kind of want to restructure this file where like this kind of stuff is like not really primary. Let's sort of put it down here. File system manipulation utilities, right? And then we'll make there is definitely what that is. Okay. And then because I just want people to be able to read this file and be like, okay, I see what it's doing. And just like reading main sort of tells you that, right? File visit helper stuff. Okay. So, we still have our game running. We still have browsers running. No, we don't even want to be building that. We want to be building package. Dang it. Okay, we aren't importing text file handler. Get where, statements in block after return. All right, well. Unable to load all that manifest. Okay. Remember when I said tell people what is wrong? Yeah. Boom. Okay, maybe we succeeded. Okay. Textures, meshes, levels. I mean, these are tables with a lot of things in them. So it sure looks like we parsed it. Like that all, like we just got it the first time, I think. GG's. We can retire from programming now. But like, you see how straightforward that was, right? And like, people make all these arguments. Oh, you gotta use Python if you want to do things. It's like, no, not really. You don't have to. You don't have to. Easy clap. So now is sort of the moment of truth where it's a little bit, we've spent a bunch of programming putting this data together of like what assets are in the game, and it's not done. Like, there's going to be probably other asset categories. Like, we're not even doing, well, I don't know. We'll see. But the way that we go and find files is we just like recursively look up files, right? So I think the way to do this is to sort of maybe block by extension. So like, we know a .texture extension is a texture. And so when we see a .texture file, we either skip it or not, right? Does Witness use a custom image compressor to load them faster? A custom image compressor. That could mean a few different things these days. If you mean like one of the modern things that you might do, like Oodle or whatever, no, because it's older than all that stuff. If you mean like, does it load JPEGs? No, it doesn't load JPEGs, because that's not how you make video games. Really, you want to load your bitmaps in such a way that they're already in a format that is fast for GPU rendering, which at that time meant, you know, one of the BC whatever formats, for example. These days, I don't actually know if those formats have been broadened particularly much. Actually, I haven't been keeping up with that. What about textures in Braid and Braid Anniversary? Original Braid did load JPEGs, but the reason was actually, it didn't load JPEGs for everything, but the reason was because Xbox 360 had a file size limit for Xbox Live Arcade games. Or no, it wasn't file size limit. It was, okay, no, it was that we had the choice of trying to load everything into memory or not. And I wanted to load everything into memory so we didn't have to delay when you go from level to level. And if we start loading things from disk, that becomes very slow, because Xbox Live Arcade had like some really messed up package format that was super slow to load. Like, I don't even know what that was all about. So, well, it was like, I need to fit all the graphical assets into memory on this console. And they didn't all fit, but JPEGs fit. So I was like, well, we're going to load JPEGs and we're going to decompress them at startup. Should traditional software have an update and care about the refresh rate loop just like video games? I mean, if it's interactive software, then yes. Well, okay, let me put it this way. In principle, there's no difference as long as your events take 0 time and as long as you're not trying to draw anything on the screen between events. But you're like, if somebody clicks a button, you're probably doing some nice animation anyway while the button, you know, or while they're scrolling or whatever. Like, so then all of a sudden you're trying to do 2 different things. You're trying to respond to events, but you're also trying to render smoothly every frame, which is weird, right? Now, all that said, you could move to a kind of a model where it's like, look, we just do this refresh rate, but the refresh rate will self-throttle if there's no input events, right? And we're not doing anything. You could do that. But like this whole event-based thing that people do, it's another manifestation of like not knowing what's going on, right? And like when does your event come in? I don't know. Where does it come from? I don't know. And it's like, well, Okay. So when we see, we're going to load the manifest. Okay, I'm going to put at the top, run the manifest command, which will generate a file called all.manifest in run tree. Copy that all.manifest to this folder or wherever you are going to run from. Okay. Okay. Great. Great. Now when we see a dot texture, all right, let's go through here. So we do our file visit traversal. We reject a bunch of extensions. We make this Xcopy is a weird thing that duplicates the folder structure without copying files. And I was like, okay, I'm fine with that. Okay. Now, so if not present in manifest is not present in manifest path continue, don't output this as the game doesn't actually use this asset. Okay, so well, use this hopefully. Because we all know that we're not catching all the assets yet, and it's going to be a little bit wrong. Okay, so we're going to put this down here. Is not present in manifest. You know what? Let's make it is present. Like, come on. Okay, so I don't want this path, actually. It's not helping me with the thing. T. T is a string. Extension is we already did this in find visitor. So we could have stored it or set an enum if it's a known extension. Well, we're doing this. Okay, so now now if extension is equal to, you know what we could do? Here's what we do. If no table return true, this is not covered by the manifest, so assume it's necessary for now. And WO. Okay. And then you know, I do want that path. Well, maybe not. It's fine. Hold on. One thing at a time. Table colon equals get table from extension line if, oh, that's not the same thing. These are not the same sets of strings. I'm a silly. Okay. And we might want multiple extent. Yeah, never mind. Table is table string to bool. If extension is equal to case texture, right? Okay. We're just going to do that for now. So we're going to go found is table find. Table for where are the path base name kind of stuff? I'm getting hungry again. It's in string. Aha. Let's do this. Okay. So base name we find, okay, if found return true log stripping asset whatever because base name whatever is not in the table. T t base name. All right. We can see what happens with that. Table find. Oh yeah, I know why that. Okay. Right, so the thing is, we are not going to call this code anymore because of this return. Wait. What? Oh, that's a not. My brain just thought it knew what it was doing there, and it didn't. All right. So now we're actually doing all the file stuff. You know what? I should have redirected this to a file. Okay. Okay. See, the problem, see, we're not rejecting. Or are we? We are. Okay, so this number is a lot lower. I believe this used to be like 4,000 or 5,000. Let's see. Let's just recompile it. Running it all again. Good thing yesterday I cut down the number of files by so much. We're now a mere 67,000 files. So the fact that we are copying 2,000 textures means that we did find 2,000 textures in the manifest. Go make a sandwich? No, it's not that slow. Although I do kind of want some water. And then maybe tea soon. Total files rejected 836. Okay. That's pretty okay. I mean, we could just, we obviously log these. Yeah, okay, we need these UI bitmaps. Maybe not the checkbox ones, but like the dragon one, like all the all these are things that show up on the HUD. Yeah, I don't actually know. I'm just going to add these to a rejected assets array that we could choose to print or not. And like maybe later if we add command line options to this, it'll be like, okay, you could print it. But it's going to be normal to strip stuff. So like I don't want to pollute the output. So files rejected is actually going to be a string array. I think actually, yeah, see, you know what? We're going to do this at a different time. We're just going to pass the extension because we already have it. If it's present in the manifest, otherwise we'll we're just going to put it there. Put her there. So by the time we get here, we will not so that way, see this count here of textures is actually counting this, and we don't want it to, because we're putting it in, we're counting per extension, and then blah, blah, blah. And it's like, look, let's just do the thing. So is present in manifest, we're going to have full name, and then extension, except extension is already lowercased for us, which is why we pass it. Okay, so and then we don't decomp necessarily. Okay. And then we're not going to log this. Files rejected. We got to put this somewhere. I don't know. Okay, yeah, so you see this texture number is lower here. Let's do this for some other things. Let's do this for material. We don't want to reject these SL files. Those are shaders, but like, I'm not sure about that. What else? Triangle list mesh. You know what? We could actually, since we're rejecting this, we could just put this in a per extension. I don't want to do it yet. We could do that though. Now the levels is kind of interesting because we have to kind of do this a different way. Yeah, we could do the level sets. It's kind of trivial to do the level sets, but because those aren't that big. But you know, all right. Before I forget, we got to go to the HUD. Control prompts. Tell me what textures you use for control prompts. Or, I mean, maybe we should put these in a specific folder. Or maybe we should make a special folder. That we know gets fully packaged. Okay. I mean, because you know this is going to break. You know this is going to... This is just not, you know. You know. Is there no UI torque? Oh, dude. Let's make sure you jam up, jam down, elevator up, elevator down, dragon. I forgot that I prefetched these level entry spawner. wand, torque, prism, mirror. Yeah, okay. I still need to get these. Why is my alarm going off? My alarm is going off because I had to go meet someone for lunch last week. Oh, wait. We want to run a new manifest. Oh, we want to, okay. We want to call this function, first of all, from here. Do I do... I don't know. MISC textures. Okay. So it's still not going to compile. Procedure call. Whoops, I declared the argument incorrectly. Lol, I put the star in the wrong place. Okay. Okay, guys, I will learn programming eventually. It's one of these days. One of these days. One of these days, manifest. Bam. Ba-bam, bam. What's up, everybody? You can use it for game development and nothing else. Well, you can't use it even for game development because you don't have it. So, you know, there's that. I am clearly not using it for game development when I write this utility that packs files together. That's like... What does manifest command do? It is going through the video game that we are making and figuring out all the things that we actually use. Because when you develop a game and you work on it a long time, you try stuff out and you make all these bitmaps and meshes and textures that maybe you don't end up using all of them in the game, right? And then if you put together a package for people to play and it has all that extra stuff, it's bigger than it needs to be. So... this is how we maybe make it not bigger than it needs to be. Okay, so we got this manifest. No, that's the wrong one. We got this manifest. It's slightly bigger. Replace. And no, let's not build that. And boom. So I guess I could try running the package. We could also see how much smaller it is. Now the thing is, it's not necessarily... So we're not screening out the unused levels yet, which might be a significant number of these files. The files are probably not big, but there are definitely levels that we are not shipping. Yeah. Okay. I don't even know about material list. Anyway, let's go see if we made it like any smaller. Because I have an export from this one, this dist pre-manifest is handily here. And that's 14.1 gigabytes, 15197, blah, blah, blah. Uh, 12.9. All right, so we saved 1.2 gigabytes of uncompressed size so far. It's not counting other things that we're going to save. So, non-trivial so far. Now, that's only true that we saved that if we're actually including everything here that we need to, which we probably aren't. Let's face it. But you know how we find that out? We run the video game. Oh, you know what else? You know what's not in the manifest? The rewind UI stuff. But we're going to pretend we don't know that right now. Okay. Materials was not able to find all these assets. And neither was textures. Okay. So already here are some things that we are not including. The editor UI missing. We should probably just throw that in there. Because some meshes, I think, maybe default to that. Now, these smash textures and all that, I think those are coming from... I think those are coming from beam rendering. the materials, these all may be materials that we set directly within the game. You know what? I'm actually not going to, let's not worry about materials yet. What we're going to do, because I don't, there's that question about the render material versus the non-render material and all this, right? So because that gives us some gray area there, we're not going to worry about that yet. In fact, all we're doing right now is textures and meshes. Materials are small anyway, so I'm not super worried about it. However, there's a cascading issue here where if we don't include a material and that material has some default texture set on it, we won't be including the texture maybe. So it's still a concern that we need to fix that, but I'm not going to worry about it yet. Okay, let me just go manifest. We're just going to go table set. Meshes, editor, UI missing. Somebody's like hammering something right upstairs from me right now. Okay. Now these ones, I wonder if I prefetch them anyway, which we would want to. Probably not. Let's see. So there's something that I've been avoiding doing, right? One thing I could do is just say everything in the texture catalog that's loaded, we obviously use. That might not strictly be true. Fuck. No matter how small you make an asset, it still needs to occupy a block in memory of a certain size. I mean, sort of. I guess that depends on other things about your system, but I mean, that's also why in computers you don't want to be in the business of conceptualizing things as individual things all the time, right? Like that's sort of Mike Acton's point. Because it is true that there's a general rule that you have some kind of per item inefficiency, right? Of some kind. You can often reduce that, but sometimes it's hard to get rid of it completely. Often it's impossible to get rid of it completely. For stuff like this, let's just say any textures currently loaded in the catalog, we know we need them. This is not strictly true if we are drawing developer-only stuff, but it saves some missing texture mistakes for now, probably. January. All right, so for texture catalog dot table for value key. If texture dot loaded table set textures texture dot name true. Like that would take care of that stuff we were doing at startup. Now that said, remember this playtest UI we did for level ratings? Remember this? Remember? I'm just going to put this in here for now, but whoops. That was just supposed to be a fast way for me to delete some things. Not sure it really helped much. So like I almost want this and this to be like the same code. I could just call init level rating at startup of the frickin' game. It's just, I don't want people to suffer the extra loading time. Like, I don't know. I don't know, man. I don't know, man. I need a third shell. Actually, not really. Not really. I can't program. Okay. Editor UI missing. We need to do we need to look it up. Find mesh catalog, that thing. Tell me what textures you use for level ratings, because I didn't rename it here. It's file scope. Not good. Not good. How dare a function name say what it actually does? I know. You've got to call it something like QK so that nobody will ever understand the program. FRGLOP. That might be a little too long. 6 letters. You know, in original Unix, the word create was too long, and that was 6 letters, so they took the E off. Okay. So we got a new manifest. And I guess we'll just like run it. Package. See, I tried to be like an original Unix person. Didn't work out for me. Package. 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 So now we're going to find some new rounds of stuff that we don't have. It's fine. Wait, how did I successfully delete all that? I guess it works if a console is in the folder, just not if... Like, how is this babby formed? What? Now I'm not even sure something happened. Okay, it's running now, guys. Okay. So here we are not getting all the textures. I guess. Okay. Because I remember seeing stone differ explicitly in the rejected list. So like... So like somehow we're not getting it. It looks good. Well, it doesn't because it doesn't have all the textures. How can it look good without all the textures? So I assume every level I go into, we're going to have this, right? Yeah, like those tiles. Now it might be, remember how I looked at the thing and I said, why am I only looking at shader color? Maybe that's it. Maybe it's something else. Or maybe I just didn't look at, so maybe there's just a field on material. Okay, so for all the materials, we actually need to add this mesh up here. This is actually a little bit dicey. Okay. Because like things are happening in a certain order here, so I have to at some point assert that I'm not violating that order. Okay, so for each material, look up any textures it might use. We look in the shader parameters, but we're not looking in other places. So the material itself has parameters. But it seems to go through the shader to get to them. Okay. So this texture 2D part that we did, whoops. So but this is on main. How do I get main shader? Main shader. Okay, let's just do this. That's not gonna really, this isn't really our problem because this isn't gonna use textures. But we're just doing it just in case. I mean, I kind of don't see, maybe it's image 2D for some reason. Yeah, so this is like backward compatible witness material stuff. Oops. This might. So one of the errors we got was stone differ, right? Now we could just run the manifest again and see if we get that. If we don't get it, we could just find an entity that uses that material and figure out WTF. Isn't stone differ also in the error messages about creation time while creating the manifest? I don't think so. Those weren't creating the manifest errors. We could look for errors, though, but those that you're thinking of were actually running the program errors. Okay. Manifest. Boom. We definitely need to do an error sweep of all this stuff. This open world error has been there for a long time, so that's just something for me to do some things with. It's a 10-4 on the T situation. You know what I'm thinking is I might just go get food because I'm kind of hungry. Problem is I have to, because I'm in San Francisco right now, I can't actually get food without driving for a while. So I might do that. And then go work from a cafe or something for a while. So maybe I won't do tea at home. Maybe we'll have to do Golden Monkey tea on a stream tonight. No DoorDash. I mean, it just takes forever to order that, and it's cold, and the driver sat on it. And, you know, like, it costs $95. Okay, we definitely, like, we're definitely getting some errors here. This is us, like, trying to look up some of these materials or whatever. Okay, so let's, before we go copy that manifest over, see. No, we didn't get it. We didn't get it. The new manifest is 5685. The old one is 56. We got literally the same manifest, probably. It's the same number of lines. All right, so that didn't solve our problem at all. So the next step would be a debugging cycle where I can break. So we have this function. I'll show you what the next step will be. So we have this function that goes through the level and adds all the assets to the manifest, right? So I can look up that level and one of those floor tiles, and I can say, what happens when we're doing the floor tile? And what is the deal? And I can just step through, and maybe I'll look at the floor tile in the editor and try to figure out where else the things are stored. But that is a thing. Another way to generate a bigger manifest, by the way, is because that thing that I put in about any texture that's loaded is just use that. We can just run the Benny test to load all the textures. It's just, I don't want to rely on that because it's kind of janky. I'd rather look at the level data and get the things. Maybe I should drive to Chick-fil-A today. Oh, they're closed Sundays. Oh, dang it. I have a Chick-fil-A urge. That has happened multiple times when I think about going there and it's Sunday. Well, yeah, so I have a mystery here, but before I attack that mystery, I want to be able to check in. So we're going to go here and we're going to say return true. Temporary, we aren't including everything in the manifest that we need to. So don't do this yet. Incomplete. Figure out the missing textures. And then incomplete. Add some code that filters out levels that we don't want. That's going to be a big reduction. Yeah, but I kind of want to take a break before doing any of this. So we're just gonna recompile this. I'm gonna make sure it runs, and then we'll check in. How important is a game looking nice to me personally? It's not about looking nice exactly. It's about the game feeling coherent and solid and meaningful and interesting. And if a game looks like complete crap, like you didn't put effort in, then it comes across that way to people, right? And it affects the actual gameplay. Would I have been happy with Programmer Art Braid? No, because it would ruin the ambiance of the game. I mean, unless I did a really good job of Programmer Art, which I thought at one point that I might have to do. Okay, entities, paint data, sound effects, SL, etc. Great. I'm nearing the 3-hour limit. Yeah. Okay, so this time we didn't get a bunch of errors. And you can see there's actually details on the stone and stuff now. Wait, unable to load level. Why is it saying that? It loaded the level, so I don't know why it's saying unable to load level. It's saying that for everyone. So that's also going to go on my list. Why does it think it's unable to load the level when it clearly did so? All right, thanks everybody for coming by. I am gonna take a break. It's a weekend anyway. I can take a little bit of a break, right? Right. Thanks everyone. See y'all later on.